Bismillahirrahmanirrahim. Good evening. Today in our lecture we will try to understand what the Thevenin theorem, and at the same time we will try to calculate the Thevenin equilibrium. But at first let's know what that means, the Thevenin theorem, why we use it. We have some benefit, some feature benefit from this theorem, because by use it we can calculate specific value, for example to current, with many unknown current values, and we can calculate this current with many different values of resistance. Here we have many steps we must follow it. At first, here, for example, if wanted from us to calculate the current IL through from this device, from this current, at first we will deal with this load by ignore it and put instead of it open circuit and selected these 2 points A and B. This is very important to us. And in my opinion here, when we say we will connect this wire with the earth point, VB will equal 0 because no voltage drop through from this point. That means VTH, Thevenin voltage, will equal VA. Let's go to deeply by using this important information. By using this example, all these steps will be easier to us. Here, find the current Ix in the circuit below by using Thevenin theorem. Here we have three different amounts of resistance, and we have just one independent voltage source. Like I said before, here we will dealing with any voltage source like open circuit, and we ignore any current source by assume it's like open circuit. Here at first, like I said before, ignore this device and put it like open voltage. Here I selected A and B. Here I have one independent voltage source. But here I need to calculate the voltage at this point, because that, let's say here it's C point, and I must calculate VC at this point. Here, like I said before, here we have few steps. We will calculate the Thevenin resistance. After that, we will calculate Thevenin voltage, because it's necessary to can determine the last value of Thevenin voltage. Here, we will say Thevenin voltage equal Vs, or here it's not Thevenin voltage. Here it's VC voltage. VC voltage will equal Vs dot RT, or we can say equal 15 volt dot 30 ohm and divided on 20 ohm plus 30 ohm. Here, to be the last voltage, the last value of the voltage, here VC, I repeat, not VTH, VC equal 10 volt. Why? Because I dependent on Vs from the author. Its known value, its known element equal 15 voltage, and try to calculate the VC here, because that equal Vs dot the 13 ohm divided on 20 ohm plus 30 ohm, to be 20 divided on 50 dot 15 ohm, to be the last value to VC equal 10 volts. Here, why I ignore it? Why I ignored this resistance 13 ohm? Because here I assumed but not assumed, it's fact. Like we know, the current will through from here to this point, because here it's open circuit, no current will through from it. Directly will come back by use this way to here. That's mean we have current just in these two resistance. I think here now everything is clear. Now let's calculate the Thevenin resistance. After we have VC, that's mean we can calculate VA equal V Thevenin voltage, but we need calculate Thevenin resistance. We have one voltage source. We assume it's short circuit, like I said before. Now let's calculate Thevenin voltage equal 20 ohm dot 20 divided on 50 plus 30 ohm to be 25 ohm. Here the last step will be draw or plot the circuit again, voltage with series Thevenin resistance, and the load device RL resistance or dependent voltage, current, doesn't matter. But here at this question, our load is the 15 ohm, is the RX, that means resistance. Here we plot the circuit. We can say we plotted the Thevenin circuit, current circuit. And now let's try to calculate IX at the circuit. The total resistance is 40 ohm, like we know, 25 plus 15. And here from Ohm's law, to calculate IX equal Thevenin voltage divided on Thevenin resistance plus Rx, or we can say RL, to be Thevenin voltage divided on 14 ohms to be equal dot 225 ampere. Here, I forget to put square here because that the last result is 0.759 watt, because I use this this rule, power rule, equal square current dot resistance. Here, dot 0.225 square dot 15 ohm equal dot 759 watt. Here, this image it's not clear because that I take another picture to it and I put it at the last. Here we have another example. Calculate the IX in the load RX equal 10 ohm. That's mean it's here. By applying Thevenin theorem, at first we will ignore this load, this device, and put here A and B. After that, we will here just we have two amounts of independent voltage source, because that all of them will be open circuit. After that, we will try to calculate the Thevenin resistance because it's important to can calculate Thevenin voltage. We have three different independent voltage source at the circuit. I forget this one, but it's not important, and we will know why it's not important. Here, it's be like open circuit. At first, we can calculate the Thevenin voltage, Thevenin resistance. But here, directly, I started to calculate Thevenin voltage. Thevenin voltage here equal VAB. We can calculate Thevenin voltage value by using Kirchhoff voltage law. And here will be I put it here C and D, because this circuit will we will divide the circuit, we can say, to two pieces, because that I put it C and D. VAC minus VAB, that will be Thevenin voltage, minus VBD from here to here, plus VDC. That means here we need to calculate VAC at first, VAC by benefit from V source number one. VAC equal VS1 dot 15 ohm divided on 15 ohm plus 5 ohm to be 20 ohms, like that, to be VAC equal 15 volts. VBD equal, by benefit from VS number 2, equal 10 volts, equal VBD or VDB, no, VBD equal VS number 2 dot 8 ohm divided on 8 ohm plus 2 ohm to be the result, like that, equal 8 volts. Now we can calculate, we can use the Kirchhoff voltage law, yes, because we calculated the two VAC and VBD. VAC equal 15 volts, VBD equal 8 volts. Here we have just unknown elements, just one, VTH or VAB, to be equal 17 volts. Now let me come back to here. Now let's calculate the Thevenin voltage or the resistance at AB. Here we ignored all of the voltage source by putting all of them like short circuits. Now we have two parallel resistance at each side of the circuit to be last value of the Thevenin resistance equal 5.32 ohms. Now we can calculate the Thevenin circuit like that. We will just put the Thevenin resistance series with the Thevenin voltage, not parallel, because it's different. We will take the situation with Norton theorem, because that will be, we will connect the Thevenin resistance always like that. And the load, the resistance device, anything, doesn't matter, will be here between these two, A and B. Now from Ohm's law, V equal IR. Now let's try to calculate IX. IX equal Thevenin voltage divided on Thevenin resistance to be 1.1 ampere. Sorry, here, not Thevenin, here R total. That's mean resistance theorem, Thevenin resistance plus resistance load, resistance device. Wanted to calculate the current to it to be 5.35 ohm plus 10 ohm to be the result at last 1.1 ampere. Now by using this values, we can calculate the power, because the power equal I square dot resistance at this load to be the result 2.1 watt. I think it's the last example. Determine the consuming power PL in the following circuit using Thevenin theorem. Here we have how much current, how much source device. We have two kinds of source device. The first one is independent voltage. The second one is the independent current. That means we have two different kinds of source at the same circuit and four different values of resistance. Now at first, PL, that means we will work on this point and we will put here A and B and ignore it, RL. Here will be open circuit. This dependent voltage will be short circuit, and we will calculate the Thevenin resistance. After that, calculate the Thevenin voltage and plot our circuit. Here, actually, we can calculate the Thevenin resistance at first. After that, we can calculate the Thevenin voltage, or that's up on you. We can calculate here. I calculated Thevenin voltage. After that, calculate Thevenin resistance. Here, by using Kirchhoff voltage law, we can put here C and D to simplify the circuit more. Here, VAB equal VA minus VB, like we know. Here, VA, we won't calculate VA. Here, that's doesn't matter to use Kirchhoff voltage law, because here we don't have another device circuit, another current or voltage device here, because this way will be easier to us. Here, VA equal, we can say the source current dot the resistance, or we can, let me say, we will use Ohm's law, V equal IR, because that VA equal I resistance 5 ampere dot 2 ohms to be VA equal 10 volts, like that. And the same situation, we can calculate VB. Yes, that will be easier. VB equal, we must have VS1 equal, its known element, equal 10 volts. That means VB will equal, by use another way. At first, I selected or used Ohm's law, because here I have the current value, but here the situation is different, because that we can solve it, but by use another way. The same trick, we used it before at the last example. Here VB will equal VS dot 2 ohm divided on 2 ohm plus this resistance to be the last value equal 5 volts. Now we have the result to both of them, VA, VB, VA minus VB equal Thevenin voltage to be Thevenin voltage equal 5 volts. Now let's calculate the Thevenin resistance by ignore the current source and put short circuit instead of voltage source. We have two parallel resistance. That means Thevenin voltage will be 2 ohm plus 2.2 divided on 4 to be 3 ohms. Now we can upload the Thevenin circuit by put Thevenin resistance here near from the Thevenin voltage at the same wire. And here the load is RL equal 4 ohm. Wanted from us to calculate the power at this load. Now we can calculate IL, because it's necessary to calculate PL, the power at this resistance, by using Ohm's law. Ohm law, V equal IR. Here, IL equal Thevenin voltage divided on Thevenin resistance plus RL to be 5 divided on 7 ampere. Now we can calculate PL by, say, square current dot resistance, or we can say V dot I, voltage dot current, the same meaning, equal 100 divided on 49 watt. That's it. Our lecture is done. Next lecture, I will talk about Norton equation and how we can calculate the Norton equilibrium, and how we can calculate the Norton resistance by use the same way with Thevenin resistance, because actually some huge similarity between these kinds of resistance. Thank you so much. Have a good day. Thank you about your patience. You're watching.